What's up, AP Psych? Welcome to your Intro to Learning and Classical Conditioning lecture. This is the first lecture of our Learning and Development unit, Unit 3, and I'm pretty excited for it. I really like it. I feel like I'm very good at this one, and so I feel really confident going into this one. And I've had feedback from students in the past that they also really like both of these topics, learning and development. There's a bunch of fun things we do with it. There's some demos. And really, the challenge is not the topics themselves. The challenge in this unit is that we take common words and make them really hard, kind of for no reason. But we still have to learn them and we can do hard things, so it'll be okay. But it's not a ton of vocabulary. I mean, it's probably on par with some of the other units, but it's just tricky because we take very ordinary things and we make them sound fancy and academic. So here are the learning targets we're going to cover in this lecture. We're going to just talk about learning in general, and then we're going to get into classical conditioning specifically. So think about it. How do you know if you or someone else has learned anything? And this is not in your notes. So I just truly want you to think about it. Like when you sit through my class or you sit through a YouTube video, how would someone else know if you learned? Would you or whoever you're talking with just say, oh yeah, I totally know that. And we accept that as evidence of learning? Like, is that enough? Is that enough for me for you to just say, oh, Miss Russ, your YouTube videos are great. I got it down. I'm good. I'm good. No, learning must be proven. Learning must impact behavior before it's considered learning. I can't just take your word for it. I need to know that it's happened. So, learning is the acquisition of knowledge or skills through experience, study, or being taught. So, whether you just do something and learn because you make mistakes and then know how to do it better next time, you're actually putting effort into studying something, or you're being guided through a topic, kind of like I'm doing right now, all of those is how you get the knowledge and skills. But then it has to result in a relatively permanent, noticeable, and measurable change in behavior. So, yes, you might acquire all the knowledge that I'm telling you through these YouTube videos, but I need to be able to measure that difference between what you knew before and what you know now. That's where tests and some of our worksheets and activities come into play. Or if you claim you learned how to make a cake, well, then make me a cake. Prove it. How do I know? Just because you watch people make a cake on Food Network doesn't mean you can make a cake or fix a car or something like that. You need to demonstrate it by making that cake or perhaps changing that flat tire. So that those things are things that we would call measurable changes in behavior. So something that you can noticeably do different because you've learned where you couldn't do that thing before. Okay, here's the first of the defining words, easy words to make them more complicated. And that first word is learning. Learning in this class is often going to be called conditioning. Conditioning is training a person or an animal to behave in a certain way or to accept certain circumstances. So I have conditioned you to come to class, take out your notes, and be ready to start right away. And maybe work with your study team. So I've conditioned you to do all those things quickly or efficiently or the way I want you to do them. That's conditioning. But I've also conditioned you to know psychology stuff. So here are the circumstances. Here's what we know about psychology, and I'm getting you to accept it. It's not brainwashing or manipulation or anything like that, because you have the ability to kind of push back and like figure out what you agree with and don't agree with and things like that. But I am still guiding you to experience and learn psychology. Learning is also the basis of the behaviorist perspective, which, if you remember, involved this naughty finger that I am putting across the screen. And the buzzwords for that perspective included learning, reinforcement, rewards, punishments, and observation. So these words are the foundation of behaviorism, which was created by this man named J.B. Watson. And he is a big deal guy. He was in 1908 the chair of Johns Hopkins University Psychology Department. He was later elected the APA president in 1915. I mean, this was a long time ago. That picture should give you a pretty good clue that that's what I'm talking about. But he wrote something called the Behaviorist Manifesto, which are essentially 3 sentences that I've summarized here about how we should be studying psychology. That the content of psychology should only be behavior, not mental processes. That we should not care what people's thoughts are, because to be scientific, to be black and white about this, official about this, we can only study or use what we see, because The method should be objective, not introspective. Introspective is kind of like metacognition, where you're asking someone to think about their thinking and then report it out. Well, humans are flawed at this process. Sometimes we lie to others, sometimes we lie to ourselves, sometimes we're not sure what we think and what we feel, and it's hard to put into words. And so we can't rely on people just reporting their thoughts. We need to work on just the proof is in the pudding. If we're going to study happiness, let's look for signs of happiness, like smiles or energetic body motions, things like that. Not just relying on somebody to be like, yeah, I'm happy. I'm fine. Okay. I'm fine. Everybody's fine. But what does that really mean? We should tell based on their actions. And that the goal of psychology should be the prediction and control of behavior rather than understanding these mental events. Okay, association is also the basis of all learning. These terms kind of all stack on top of each other. So association, also known as acquisition, is when the mind naturally connects stimuli together or certain events occurring in sequence. So in a fancy way, just connecting ideas, that's learning. You're learning right now by connecting these definitions and these examples to the word association, to the concept of learning, to the concept of psychology. Okay. So in your notes, let's see if your mind will naturally connect two stimuli together by telling me, by writing something down. What do you think of when you hear Santa and what? I'm not going to tell you what I think of. I want you to write something down in your notes, and we will compare our notes when we're all together in class and say, what did you write down for Santa? What did you write down for Santa? What did you write down for Santa? To see what associations we have. What have we learned goes with Santa? Or perhaps we've learned that one stimuli triggers an event, or in one event follows another event. So, like the school bell rings, and what do? Write it down, and we will see if we have matching associations when we report out in class. Okay, here's a few more words that we're going to make more complicated than necessary. You need to know a stimulus. A stimulus is any event or thing that a subject responds to, not responds to, sorry, responds to. Correct my grammar in your notes, please. For example, a flash of a light, a smell like, oh, that was weird. I said flash of a light and I just was distracted by my phone because it just lit up that I have two text messages from Miss Hanson and from Miss Crane, actually. So a stimulus, a flash of a light, a smell of food, an alarm going off. So things that we respond to. So how do those things, do we respond naturally? Do we have to learn to respond? Are they nothing? More on that to come. The response is the reaction or behavior to the stimulus. So there's no example here specifically because I break it down into two. When you see that flash of light, the smell of food, an alarm sound, or a million other things that could act as a stimulus, if it's an involuntary response, it's an automatic body reaction. Does something make you blink, turn your head, sweat, respond to a strong emotion? Like if you're scared, do you jump? If you're grossed out, do you kind of cringe, like, oh, gross? Where you feel like you can't help it. I know one of my responses that feels involuntary is I roll my eyes a lot when I get irritated or I think something silly. And so that is actually involuntary, but I should try to learn to control it. Okay, on to voluntary. Speaking of, it's any behavior done by choice. So perhaps following a rule, doing something for a prize, completing a task. So responding, like for me, I saw that flash of light. It felt involuntary that I glanced over to see what my phone was doing, but I guess it was also sort of a choice to react to it because it fit in with what I was saying. I could ignore it. Neutral is something that elicits no reaction or behavior. So perhaps like a color, like, ooh, that box is gray. That shouldn't make you think anything. It's just a gray box. A normal noise, like I can hear my window rattling because of the wind. That's not actually making me react. It's a noise that I can ignore all the time. It's an old window. Or an event that you don't necessarily need to respond to, like perhaps at school, someone walks past in the hallway and you don't know them, so you don't react. So all of these would be neutral stimuluses, something that just means nothing. Then we have unconditioned, which means naturally existing, like untrained. Like we could have an unconditioned stimulus or an unconditioned response. The fear of loud noises would be both of those things. When we hear a loud noise, like if there was something dropped down the hall in my house here, I would probably be like, "Hey, Mr. Russ, are you okay?" I wouldn't call him Mr. Russ. "Hey, Schmoopy, are you okay?" I might say something like that. Like it is natural that if I hear a loud noise, I'm going to see if everything's okay. And then condition. Learned, has been taught, or trained. Let's talk about the fear of lightning. Write that down. Actually, I'm going to talk about that on the next slide. So for the moment, that is conditioned, it is learned. You have to learn to be afraid of lightning. More on that in a second. None of these words, all of these words in this chart, are good or bad. It's not about this is a good thing to do or a bad thing to do. This is the right thing to do. This is the wrong thing. These are just definitions that we're going to be using over the next 3 or 4 lectures, and so they're just words. Okay, let's move on to why I'm referring to loud noises and lightning and how that is a learned reaction. Actually, let me ask you this before I have you do that. Are you automatically naturally afraid of lightning? Are you? You might be inclined to say yes, but probably not. Here's why. This is going to be our introduction to the concept of classical conditioning. We're going to learn also about operant conditioning later. So we're just going to focus on classical conditioning right now. This is when learning is based on the association of one stimulus with another to elicit a response. Again, fancy words. But what it's saying is if you put two stimuluses together and you learn that they go together, you're going to get a response. So for example, lightning is we associate or we learn to put that together with thunder, that they always travel together, so to speak. And then that's where the fear response comes from. But a flash of light outside in the sky is interesting. Oh, cool. Look at that light. Like if someone takes a picture and you see the flash, like there's a light. Think of all the lights we see in the sky and we don't really react to it all. Like, oh, there's a flash up there. That must be an airplane. It just is. But when you pair that with the loud noise of thunder, especially if it makes the house rattle, you are learning fear. So the fear is actually attached to the thunder. But because we associate thunder and lightning together, that is how we learn to be afraid of lightning. So with classical conditioning, we're pairing two things together and seeing how they create a reaction in humans or other animals. But again, more on that later. So we need to think to ourselves, what is the stimulus? So the first stimulus in this case is the thunder. Another stimulus is the lightning. And what's the response? The response is fear. And was that natural or learned? So classical conditioning associations are developed between a natural stimulus that creates a natural response. So like loud noise, thunder, creating fear, and then a neutral stimulus, a flash in the sky. And by putting those together, we can turn something that's neutral into creating a response or a reaction. So ultimately, and I'm going to give you a ton of examples of this. So if you're not quite with me, get it down. Like so many examples, you're going to be sick of examples. Okay, we're going to get this down. Ultimately, a person or an animal is being conditioned or is learning to pair their response to the neutral stimulus. So I'll give you one other example before I move on to the million billions of other examples. Think about um, think about hearing the bell at school. When you hear the bell, you are conditioned to get up and switch classes. Okay, you had to learn that. That tone, that bell that the school uses, or going all the way back to like middle school or I guess maybe elementary school when you first started hearing bells, you had to learn that that bell meant something. So it was a neutral stimulus at first, and you paired it with someone telling you, and now it's time to switch classes, or now it's time to go home. Okay, so something neutral that's paired with something natural, like knowing you are released from where you are to want to leave. Okay, taste aversion is one of the simplest types of classical conditioning because it is also what we would call one trial learning. So taste aversion is when we associate a bad experience with a particular food. So perhaps we experience food poisoning. So this is a super simple example of classical conditioning. So you guys probably know by now that I hate eggs of all kinds. I think the worst is scrambled eggs, but I really hate all eggs. And I think I had a childhood incident where the smell or the fact that they bounced or something like that made me sick, made me gag. And it only had to happen once. Like I had one bad situation with eggs and I never want to eat them again. Ever, ever, ever. I have zero interest in trying it. Just try it, see how it is. No, it took one bad incident with eggs that makes me want to never have them again. So some classical conditioning, usually it takes more trials. Usually it is over and over and over again. It demonstrates, but taste aversions demonstrates one trial learning. When association is acquired through one pairing of stimulus and response, one time of eating the egg with getting sick from it, and I'm good. I don't need to strengthen this response with further pairings. I didn't need to have that happen over and over and over and over again for me to learn to associate those two things together. Happened once. Why is that all it took? Because of something called biological preparedness. Animals are biologically predisposed to learn certain stimulus response pairings more quickly than others. It's a built-in readiness to form associations for the sake of survival. Make sure you write that in your notes because I think I have it, the sake of ... survival. So before I go on to this example, let me talk about my egg thing. If I eat food that is poisonous or bad for me, it only takes me getting sick one time to be like, that's not a good idea. Because if we go back to caveman thinking, if I eat a berry and the berry is poisonous, I go, that was gross. I never want to eat that again. That protects me. So food, if it's bad, has the potential to make me sick or hurt me in a really serious way. I only need one time to learn that to get it down. Something like a bell and then switching classes, that's not survival based. So that one probably took a while. But there are certain things that psychologists think because they're biological in nature and have to do with survival or maybe reproduction. I'll have to think about that one a little further. We learn them quicker. So a couple other examples for you. There's an innate, born-in human ability to recognize a knife as a threat and as a tool. So we recognize that it being sharp, it can both hurt us, but it can also be used. So we've done research, or not we, but psychologists have done research on humans and other animals to see that at a very young age, we learn very quickly that a knife is something to both be concerned about and be careful with and potentially use to help us. Another example, some apes are biologically predisposed to detect and be afraid of snakes faster than other creatures. How is that advantageous for some apes? We will check back on that in class. And the last thing is habituation. This is a term that occurs when organisms grow, so organisms meaning humans or animals, just shorthand, grow accustomed to and exhibit diminished or weakened response to a repeated or enduring stimulus. That is so many fancy words to say something super basic. It basically means we stop paying attention to things when we get bored. How about that? So it's a weakening of classical conditioning. So if we get used to something, it's like sensory adaptation. We'll talk about that in a second. When we get used to something or bored of something, we're going to we're going to ignore it, okay, to the point of ignoring it. So we learn to pay attention, pay attention, pay attention. And then at some point, we're like, you know what, we're good. We don't need to keep responding to this thing over and over again. So we see this in infants and I'll show you a video at some point, I think. As infants are repeatedly exposed to a stimulus over and over again, they seem to get bored and they look away sooner. This is actually proof of learning. Like I'm a baby and I'm staring at something, maybe the mobile above my crib or the funny stuffed animal, and I'm looking at it, I'm looking at it, I'm looking at it. I'm like, okay, now I know what that is. It's not that interesting anymore. I look away. I'm habituated to it. I'm bored with it. I no longer need to pay attention to it. This should sound a lot like sensory adaptation that we learned about in our sensation topic. Sensory adaptation, I'm going to jump right to my examples on the bottom, is when our senses, our sensory neurons stop firing pew, 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 pew at that smell, at that ring that's on my finger, at the sense of cold in the swimming pool. Our receptors stop responding, and this is involuntary because our body's like, no, we got it. I don't need to keep feeling that cold water. I don't need to keep smelling that smell. Habituation is super similar, only it's instead of the stimuli being continuous, like a continuous cold pool, it's repetitive. Like if I just start tapping, at some point, you're going to be like, I hear you tapping. I got it. I got it. Right now, it might be annoying, but if this were going on in the background all the time, at some point, you would get used to it and bored of it and stop paying attention. But if I told you to pay attention to it, poof, you would. Okay, so the response can be consciously or actively controlled. So, habituation, our examples, or my examples that I have, is over time we tend to ignore examen or the announcements in the morning of school because, like, we got it. Well, we should listen. We definitely should. But because we're habituated, because it's so familiar, we're so used to it, we're like, yeah, I don't really need to listen. Or think about a time where you've been answering test questions or multiple choice and you totally missed that it said, instead of saying, what concept is this? Maybe the direction said, pick out the concept that it is not. And you weren't paying attention because the directions were so repetitive, you didn't even notice that the directions were different. Okay. All right. I think that's it. Here's your little taste of classical conditioning. But the next lecture, we're going to go deep into Pavlov's dog and all the fun classical conditioning demonstrations and examples that I keep promising you. Okay, that's it for now. Bye.